Okay, today we're going to be talking about section 4.5, which is graphs of sine and cosine functions. And since we're graphing sine and cosine functions, it's super important that you have your unit circle out so that you're understanding where the values come from. So the very first thing we need to understand is we're normally graphing x and y values. Whenever we graph something on the coordinate plane, we're graphing the x coordinate, we're graphing a y coordinate. Today, our x coordinates are going to be known as the angles. Okay? They are the angle measures. They're going to be your quadrant angles, your 0 degrees, your 90 degrees, your 180 degrees, your 270 degrees, your 360. We are not going to use degree measures, but rather we're going to use radian measures because degree measures are not on our yardstick and our tape measure. We can't actually use them to measure distance. We actually have to use the radian measure. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Then the y value is going to represent our trig value at that particular angle. For example, if I'm talking about the sine function, that is the y coordinate of the ordered pair attached to those 3 or those 5 quadrant angles I just talked about. Okay, so here we go. Our graph of sine is going to be y equals the sine of x. So if I'm graphing y equals the sine of x, you are going to use your quadrant angles. Your quadrant angles are going to be these angles that fall right here on our axes, okay? So we're going to have 0, we're going to have pi over 2, we're going to have pi, we're going to have 3 pi over 2, and we're going to have 2 pi. Those are our quadrant angles. So if I ask you what the sine at 0 degrees or 0 radians is, okay, I need you to go ahead and put the ordered pairs on this axis here. So this is going to be the point 1, 0, and over at pi it's going to be negative 1, 0. At pi over 2, it's 0, 1, and at 3 pi over 2, it's going to be 0, negative 1. These are the values that you need, okay? So I'm simply just going to plug all of these in. So it's a plug and chug. Now, what I need your brain to grab is the y coordinate of every one of these ordered pairs. That's what I need your brain to grab. Why the y coordinate? Because I am doing sine, and sine is the y coordinate of those ordered pairs. So the sine at 0 is understood to be 0. So I would graph the ordered pair 0, 0. At pi over 2, my sine value is 1. At pi, my sine value is 0. At 3 pi over 2, my sine value is negative 1. And at 2 pi, my sine value is going to be back at 0. So what does this mean this thing looks like? Well, we're going to graph that. So my height is going to be at negative 1 and positive 1. Okay? And then what we're going to do is we're going to have pi over 2, pi, 3 pi over 2, and 2 pi on our x-axis. Now, what happens is at 0, I'm going to have 0. At pi over 2, I'm going to have a height of 1. At pi, I'm going to have a height of 0. At 3 pi over 2, I'm going to have a height of negative 1. And at 2 pi, I'm back to 0. This is one cycle around our unit circle, making this function look like max, level, min, level. Okay? So we are going to have this level, maximum, our level, our minimum, and back to our level. Okay? So this is what the sine function is always going to look like. Now, that goes to our next function, which is going to be cosine. And again, I'm going to go ahead and I'm going to put these points on here. 1, 0, negative 1, 0, 0, 1, and 0, negative 1. And this time, I want the x value of every one of these. So if I want the x value of every one of these, I highlight the x coordinate. Okay? So now, I'm still going to be using 0, pi over 2, pi, and 3 pi over 2, and then the last one, 2 pi. Why? Because those are our quadrant angles. Okay? And I'm simply going to plug each one of these in. Cosine at pi over 2, the cosine at pi, the cosine at 3 pi over 2, and then the cosine at 2 pi. Okay, so from there, the cosine at 0 radians is going to be 1. The cosine at pi over 2 radians is going to be 0. The cosine at pi radians is going to be negative 1. The cosine at 3 pi over 2 is going to be 0. And my cosine at 2 pi is going to be back at 1. So what does this thing look like graphically? I still have a height of 1 and a depth of -1. And I still am going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi on my axis. Okay? So now we're going to go ahead and graph these. At 0, I'm now at the value 1. At pi over 2, I'm down to 0. At pi, I go all the way down to -1. At 3 pi over 2, I'm back to 0. And at 2 pi, I'm back to 1. Now, these need to come over like a curve. This is what I call handlebars. Max, level, min, level, max. Okay, so I have a maximum, I have a level, I have a minimum, I have a level, and I'm back up to a maximum. That is what our cosine graph looks like. Now, obviously, these two graphs look ridiculously similar. Okay? Since they do look ridiculously similar, it's super important for your brain to understand that they are technically different. I can make a cosine graph look like a sine graph. I can make a sine graph look like a cosine graph based upon domain. Okay, but this is one cycle around the unit circle, and that's what it looks like. So with that being said, our cosine function and our sine function is this right here. So if I am looking at this, the sine value, I have a pattern, level, max, level, min, level. Okay, you will have one hump and you will have one valley. What do I mean by that? You will see that. However, if I have a negative sign, well, now I've swapped it. Instead of having level, max, level, min, level, I now have level, minimum, level, maximum, level. Okay? Super important that you understand what this negative does. That negative flips the pattern and changes your max and your mins. It does not change your levels. Okay, cosine. Cosine looks like handlebars. So I have max, level, min, level, max. However, if I'm going to be doing the other one, it's going to be this. Min, level, max, level, min. And that is whenever we have the negative out in front of the cosine. It changes, again, it changes our pattern with our level and our maxes. That's what's important. I need your brain to understand. Okay? So, remember whenever we did y equals a parenthesis x minus h quantity squared plus k? A was responsible for the stretch of the compressed factor. Okay? H moved it left and right, and k moved it up and down. Well, that is exactly what is going to be happening with our a sine of b times x minus d plus c. A is what we call the amplitude. It stretches it up and down, makes it really, really high, makes the maximum high, makes the minimum very low. Okay? B is what we call the phase shift. It's what's going to change the period. In other words, am I shrinking it or am I bringing it back down? And we'll talk about that here in a second. D moves it left and right. And then C moves it up and down. C moves it up and down. Okay? Super important for your brain to understand. So let's go ahead and have some terms here. A is your amplitude. Jupers. I keep grabbing the wrong tool. A is your amplitude. It's the height of the graph. And what I need your brain to understand is that you're always taking the absolute value because it is a distance. And amplitude is always positive because it's measurable. Now, what your brain needs to understand is if it's negative, it flips the pattern. So please be careful with that. Okay? B changes the period. It takes one revolution to get around the unit circle. However, if I change the period, I want you to consider this talking about your heart rate. So if I'm just normally walking, my heart rate is going to have a rhythm, and that rhythm is going to be 0 to 2 pi. That is the norm. However, if I'm running super, super fast, what happens when you run is you are going to have one cycle completed quickly because your heart is beating so fast. Okay? So it's going to take this section that is this long, and it's going to say, oh, I can complete it in this amount of time rather than this amount of time. Okay? So that's kind of like the slinky is super close together. Okay? But whenever I'm sleeping, it may take longer. My heart rests even further and slows down, and that's a stretching that slinky out, and one revolution is going to take much longer than 2 pi units because my B value has changed my cycle, and it's going to make it longer units before I can complete one revolution around the circle. So that's what b does. b is always known as 2 pi divided by the absolute value of b. And then our increment or our intervals to go from one quadrant angle to the next quadrant angle to the next quadrant angle is going to be your period divided by 4, because we have 4 sections that we're going to be utilizing. Okay? C is your number of units the graph is shifted up or down. What does that impact? Well, that's going to impact your level and your minimums and your maximums. So how do I find this? My level is going to be 0 plus or minus C. Your level is going to be plus your amplitude, and your minimum is going to be your level minus your amplitude. Okay? So those things are super easy for us to be able to calculate. So what we're going to do is we're going to go straight into tonight's notes. Okay? And how do we go about doing that? We are going to be talking about this example right here. Y is equal to 2 times the cosine of 3/4 x minus 1. Okay, so the very first thing I want you to find is your amplitude. So my amplitude is equal to the absolute value of 2, which is just 2 units. Okay? What this means is our maximum is going to go up 2 units from wherever our level is. And it's going to go down units from whatever our level is as well. Okay? From there, I want you to go ahead and tell me what your vertical shift is. What is happening to this thing? Well, my vertical shift is going to be this right here. My vertical shift means that I'm going to put this thing down 1 unit. Okay? So what this means is it is taking every one of my max, level, and min values and it's shifting them down 1 unit. So typically our level is at 0, but it's going to change because of that. Okay? Now, what this means, I want to teach this exactly the way I have your worksheet done for you. So give me 1 second. Okay, so the amplitude is the next thing that I want you to do. Then after we do our amplitude, we talked about our vertical shift. Then I'm going to go ahead and I am going to ask for your period. The period is what is happening to this function. It is always 2 pi divided by the absolute value of b. 2 pi divided by b. b in this case is going to be 3/4. So that's 2 pi divided by 3/4. When you divide by a fraction, you're actually multiplying by its reciprocal to give you 8 pi over 3. Now 8 pi over 3 is larger than 2 pi. So since 8 pi over 3 is greater than 2 pi, what this means is we have stretched it out. And it's going to take longer for me to complete 1 revolution around the circle than what I typically would. So I'm more at rest than what I normally would be. Okay? So after we find our period, the next thing I want to do is I want to find our interval. Our interval is going to be our period divided by 4. So I'm going to have 8 pi over 3 divided by 4, so that's 8 pi over 3 times 1/4. That's going to reduce down to 2 pi over 3. What this means is, for me to land on my quadrant angles nicely, like I had in my previous example, I'm going to add 2 pi over 3 units for my calculation. Okay? So next, I need to find my max, level, and my min. So I'm going to find my maximum, and my level, and my min. Okay, my level is done by 0 plus or minus c. So that's going to be 0 minus 1, which is -1. My maximum is going to be my level plus my amplitude. So that's going to be -1 plus 2, which is 1. And that's my maximum. Then my minimum is going to be my level minus my amplitude. So that's going to be -1 minus 2, which is -3. So the only values that I should have for my y coordinates are going to be -1, 1, and -3. If they are not -1, 1, and 3, then I have screwed up, and we need to make sure that we are correct. So the next thing we're going to do is we're going to make an xy table. So our xy table is right here. And basically we're going to go ahead and we're going to do 0. Okay? I'm going to grab my calculator up here so that you can see exactly how I'm going to do this. We always are starting at 0 today. We are not doing a phase shift left and right. We're not moving left and right where we're going to change our starting point. So on today's worksheet, which is 4-5, worksheet 1, we are always starting at 0, and we're going to add our interval until we land on our period. Again, I repeat this. You are going to start at 0, and you are going to add your interval until you land on your period. So here we go. So I'm going to go ahead and I'm going to so I'm going to say 0 plus our interval that we found was going to be 2 pi over 3. So the very first thing I'm going to have is going to be 2 pi over 3. Do we see that? Because 0 plus 2 pi over 3 is just simply 2 pi over 3. Now I'm going to use my calculator, and I'm going to go ahead and keep pi as kind of like a variable in my head. So if I do that, I'm going to have 2 divided by 3 plus 2 divided by 3. And that's going to give me 4 over 3. So I come back over here, and this next one's going to be 4 pi over 3. Now, to get my next point, I'm going to add 2 pi over 3 to that. So I'm going to go back to my calculator. I'm going to say plus 2 divided by 3. And that's going to give me 6 pi over 3, which is 2. And there we have our 2. Okay, and I'm going to go ahead and write this as 2 pi so that you understand they're the same thing. Then we're going to go ahead and add again, and that's going to give me 8 pi over 3. How do I know? Because 6 pi plus 2 pi is 8 pi over 3. So at this point, we're going to have a plug and chug. So I'm going to have 2 times the cosine of 3/4 times 0 minus 1. I'm going to have 2 times the cosine of 3/4 times 2 pi over 3 minus 1. I'm going to have 2 times the cosine of 3/4 times 4 pi over 3 minus 1. This is going to be 2 times the cosine of 3/4 times 2 pi. And lastly, this is going to be 2 times the cosine of 3/4 times 8 pi over 3 minus 1. Okay, now I wrote all those down because our brain needs to understand what our level is, what our maximum is, and what our minimum is. Well, we already said our level is -1. And then we said our maximum was going to be plus 2 of that to give me 1, and our minimum was going to be minus 2 of that to give me -3. Those 3 values are the only values that go over there. So now let's do this. What is 3/4 times 0? That is just 2 times the cosine of 0 now. And what is the cosine at 0? Well, I'm going to show you this just so that you can remember. 1, 0, 0, 1, -1, 0, and 0, -1. The cosine at 0 is 1. So if that's 1, that means I have 2 minus 1, which is going to be the value 1. Now, your brain needs to remember what your cosine pattern is. Your cosine pattern, what we had found out earlier, cosine pattern is max, level, min, level, max. So if I come back over here, I should have a maximum, a level, a minimum, a level, and a maximum. 1 is what I got when I did this calculation. That is my maximum value, so I know I did that correctly. I'm right. So let's come here and do the next one. So this is going to be 2 times the cosine. The 3's cancel out, and 2 over 4 is going to give me pi over 2 minus 1. What is the cosine at pi over 2? That's going to give me 0. Times 2 is going to give me a 0. Minus 1 is going to give me a -1. Again, that's what my level is, so I know I did it right. So I'm going to do it again. This is going to be, the 3's cancel out, the 4's cancel out. So I have 2 times the cosine of pi minus 1. The cosine of pi is going to be -1. So now I'm going to have 2 times -1, which is -2, minus 1, which is -3. Again, I'm right. Now, once I have shown 3 of them, and I have my max, my level, and my min, I don't really need to do the rest of this because I already know what the pattern is going to be. I know that that is my pattern, which means if I go ahead and I graph this function, the graph of this function is going to look like this. I have a height of 1 0, -1, -2, -3. There's my graph, okay? That's my height and my depth. And I'm going to put on here 0, then I'm going to have 2 pi over 3, then I'm going to have 4 pi over 3, then I'm going to have 2 pi, and lastly I'm going to have 8 pi over 3. So at 0, I'm going to have the point 1. At 2 pi over 3, I'm going to have the point -1. At the point 4 pi over 3, I'm going to be at -3. At the point 6 pi over 3, I'm going to be at -1. At the point 8 pi over 3, I'm back to 1. Now remember, this looks like handlebars of a motorcycle, right? So there's my graph, and that is what the graph of this looks like. Okay? So I'm going to start your homework with you. This is your homework. So let's go ahead and I will be right back to start your homework.